My talk is devoted to a new fundamental phenomenon, self-organization of water molecules over 11-year solar cycle. The solar energy exerts a strong influence on the Earth. It is sufficient to say that even the earthquakes on the Earth are modulated by the sun. The solar radiation consists of electromagnetic oscillations and the so-called solar wind, which is a stream of particles, mainly electrons and protons. The electromagnetic oscillations, this is infrared light, visible light, and ultraviolet, reach the surface of the Earth and makes possible the life on it. In contrast, the solar wind is absorbed by the atmosphere and doesn't reach the surface. However, the solar wind generates in the upper atmosphere secondary particles, muons. We have found that muons exert a strong influence on the self-organization of water molecules in water clusters. We have devised a method which allows measuring this influence precisely. This method is shown here. On mixing water with acetonitrile, we do not receive a solution of single water molecules in acetonitrile. Instead of this, the formation of water clusters in acetonitrile takes place. We have found that muons generated in the upper atmosphere by the solar wind destroy water clusters. Small clusters destroyed by muons are chemically much more reactive than large ones. That is why, under the influence of muons, the same solution of water in acetonitrile can have different chemical reactivity because it can consist of a small number of large clusters or large number of small clusters. To determine quantitatively the chemical reactivity of water clusters under the influence of muons proved possible by measuring the rate of hydrolysis of triethylphosphite 1 into diethylphosphonate 2. The conversion rate of this reaction can be quickly and accurately measured by nuclear magnetic resonance spectroscopy. Regular measurements of the rate of hydrolysis of triethylphosphite in acetonitrile were started in 2015. This year was in the middle of the 11-year cycle, and the solar activity was higher. It was found that this reaction doesn't obey the law of chemical thermodynamics. At constant temperature and concentration, the rate of this reaction is highly dynamic and displays very large annual variations. In January, the reaction was very slow. Then in March, it started slowly to grow. And at the end of June, sharp acceleration took place, and the reaction became very, very fast. This was till the end of August, and then it slowed down again. In December, the rate didn't return to the level of the beginning of the year, and exceeded it about 2-3 times. Thus, in 2015, the rate of hydrolysis of triethylphosphite changed within a very wide range. The difference between single experiments in January and in July reached 200 times. The acceleration of the hydrolysis rate in summer and slowing down in winter means that influence of muons on water molecules depends on geographic latitude and can be different in the northern and southern hemispheres. One more important conclusion is that this reaction displays distinct diurnal variations because of the rotation of the Earth around its axis. In the morning, the reaction rate is usually lower and rises by noon, up to 2-4 times, and then it slows down again. Further measurements showed that the annual variations in the rate of this reaction are different each year and correlate with the variations in solar activity during the 11-year solar cycle. In 2016, a very large annual acceleration of this reaction took place again. However, the reaction was very fast already in April and May. In December, the rate was low again. In 2017, a noticeable lowering of activity was observed. The difference between winter and summer rates became less pronounced. This year, another interesting phenomenon was observed. On August 21, a solar eclipse took place, immediately after which the rate of hydrolysis decreased sharply for 5 days. In 2018, the slowing down of the reaction became especially strong, and by the end of the year, the reaction rate decelerated unprecedentedly. In this year, 4 extremely sharp accelerations of short duration took place, which could be caused, for example, by the coronal mass ejections on the sun. In September and November in 2018, these investigations were also conducted in the south of Germany, in Stuttgart, which is 1,500 kilometers away from Kiev. In both places, the rate variations were identical. The only difference was that in Stuttgart, the reaction was constantly about 50% faster because of the difference in geographic latitudes. In 2019, a further decrease in the rate of hydrolysis was observed. The summer acceleration was much less pronounced. Thus, the 5-year measurements showed that the rate of hydrolysis every year has different annual rate variations, and from 2015 to 2019, a general deceleration of the reaction took place. This deceleration is in a good agreement with the decline in solar activity in the 24th 11-year cycle, which ended in December 2019. In January 2020, the new 25th cycle began, and the solar activity started to grow. This is also observed in the rate of hydrolysis. In the first 5 months, the reaction rate was slow, and then it started to grow intensively. These results convincingly confirm that the water activity is modulated by the 11-year solar cycles. Now about the mechanism of this reaction, of this phenomenon. The fact that the solar wind influences water clusters by means of muons is confirmed with the following. The intensity of muon flux displays diurnal and annual variations, the same as the rate of hydrolysis of triethylphosphite. One more confirmation was obtained by conducting experiments underground. Because of the absorption of muons at the depth of 100 meters, triethylphosphite hydrolyzed 10 times slower than on the surface. An interesting evidence of the influence of muons on water was also found in the fact that by means of this reaction, the anisotropy of muon flow can be observed. We have found that the same reaction mixture in several NMR tubes, positioned in different directions, display noticeably different rates of hydrolysis. This difference changes during the day. The largest day change displays the tube in the direction east-west, along the line of the sun movement on the sky. Taking into account that water is the necessary constituent in all forms of life, the influence of muons on water accounts for such important biological phenomena like circadian, circannual, and 11-year rhythms. For example, it has been recently found that owing to the 11-year cycle of solar activity, annual growth rings in trees have different thickness and are arranged in 11-year sequences. The influence of muons on water molecules also sheds light on water memory mystery. Water memory is the ability of water molecules to memorize the biological effectiveness of dissolved compounds. However, this phenomenon still cannot be reliably confirmed because it is not always reproducible. Now it is clear that this instability is accounted for by the dependence of water properties on deviations of solar activity. And conclusions. The obtained results allow us to draw the following conclusions. The ability of water molecules to self-organize is modulated by the 11-year cycles. Second conclusion is measurements of the rate of hydrolysis in different places can provide important information about the influence of space weather on the Earth. And last conclusion, the influence of the sun on water depends on geographic latitude. At the equator, such measurements may become an independent method for assessing solar activity. This is all. Thank you very much for your attention.